Good afternoon. My name is Peter Friese, and I'm a developer advocate with Google in our developer relations team in London. And I'm excited to be here and to be talking to you about Google Play Services. Oh, this clicker isn't working too good. Let's try again. All right. So how many of you here are Android developers? Well, like develop applications for Android. Okay, so half of you, I guess. How many of you develop applications for Android and iOS? Okay, good. Because it's interesting to see if like the cross-platform promise of Xamarin actually is being used. All right, so Google Play Services is one of our APIs, or a set of APIs. And the question is, what exactly is Google Play Services? And I'm going to give a short introduction on this, and then we'll have a look at how to use it in your applications, and have a look at a few of the services that are available. Well, I'm sorry. All right, so Google Play Services is a set of APIs by Google that are available for devices that run on Gingerbread and higher. So by using Google Play Services, you actually reach almost all of devices that run Android out there. Only a very tiny fraction of devices out there that run Android can't run Google Play Services or don't have Google Play Services. The question is, why do we actually have Google Play Services? Because we do have the Android platform, so why don't we put all the stuff that we have in Google Play Services into the core platform? So the answer to that is, by using Google Play Services, we are able to deliver the latest and greatest in mobile technology to your users or to you on a very regular basis. So we don't have to wait for yet another release of the core Android platform, but we can ship Google Play Services on a very regular basis. And we're actually doing this every few weeks. So very frequent updates. And the way it works usually is that Google Play Services get rolled out to target devices over a couple of days. So as soon as they begin to roll out, we will roll out to a selected subset of devices. And then we will roll out to more devices, until we reach 100%. This is an important thing to know because when you're writing applications that make use of Google Play Services, you need to query if the version you are targeting is actually available. But we'll have a look at that later. And Google Play Services also is a means of connecting to our backend services in a standard way. So there is only one client that you need to use and one way of authorizing and connecting. So that's pretty useful, so you don't have to deal with different authorization mechanisms depending on the APIs that you use. From an architectural point of view, it looks a little bit like this. You've got your application, which is in blue, which connects to the Google API client, which is delivered to the device as a part of Google Play Services library, which is an APK which sits on the device. So when you connect to the Google API client, you can then connect to all the backend services that we offer. For example, Drive, Maps, Google+, Wallet, Google Game Services, and many, many more. So how do you integrate Google Play Services in your application? So it's actually pretty simple. You add Google Play Services to your project. You start using our APIs, and then you profit. But unfortunately, it's a little bit more complicated than that. So here's how it works. First of all, when you use Xamarin, you create a new Android project, like this. Then you need to ensure that you've downloaded Google Play services, and those are the packages that you need to download. You need to ensure that you've got the Android support repository. You need to ensure that you've got Google Play services itself and the Google repository. Those are the essential bits that you need. The next thing you need to do is to get the Nugget component. And this works like this. So you select your project. You click on Add. You add a package. And then you search for Google Play. And there you get the component, add it to your project. And then you end up with a few additional packages highlighted here. And then you can start using Google Play services. But not quite yet, because you have to create a new project on the Google Developer Console. So sign on to developers.google.com. Go to the Developer Console, create a new project, choose a name for your project. You can choose a project ID if you like, or just use the one that we auto-generate for you. Next thing you need to do is to configure the consent screen. So this is one of the things that's really, really important. If you don't do this, you will end up getting a lot of very strange error messages. So it's really important you do this. One of the things that, if you don't do this, doesn't happen is your email address isn't chosen. So it's up here. So you need to ensure that this is filled in. You also need to provide the product name. It's a good idea to provide the homepage URL and a link to the logo. And this will end up on the consent screen, which is being presented to your user when you let your app authorize against Google Play services. So they need to consent to you accessing Google Play services on their behalf. All right. Finally, you need to create a client configuration. And this is another stepstone where you can make mistakes. So if you are like me, you have got the Android SDK installed on your machine, and then you might have Xamarin installed on your machine. So you have two different Android SDKs on your machine. The one that's being installed by Xamarin is installed in this folder. So in my home directory, on the local share Xamarin Mono for Android. And the default Android SDK is installed somewhere else. So if you set up your developer console project and you want to take your debug key, like it's being displayed here, and you just jump to Stack Overflow for finding the correct command line, and you use the command line that you get on some Stack Overflow question, you're likely going to use the wrong certificate fingerprint because you're using the one that's intended for your Android SDK and not for the Android SDK that you use for Xamarin. So make sure you use the right one. So this is the command line which you should use for getting the correct fingerprint if you're using Xamarin. And the fingerprint is the SHA-1, which is displayed on the bottom of the screen. So you take that one, take it to the developer console, and insert it down there. Finally, don't forget to activate deep linking, because many of our APIs require you to basically jump out of the application, go somewhere else for authorizing and then coming back into your application and doing something else. And for this, in order to work, you need to activate deep linking so your application actually can parse the link that's coming back and jump back into your application. And finally, you can go to the developer console and select the APIs that you want to use. So we've got a whole list of APIs that are available for you to use, and you need to activate them as you need them. All right, so connecting your application with Google, how does it work? Let's have a look at some code. So the first thing you need to do is check for a compatible GMS version, GMS being the short code for Google Play Services. So, So we've got a utility method you can just call. It's called is Google Play Services available? And it will tell you if Google Play Services actually is available on your device. If not, you need to either display an error message or silently fail and make sure you don't use the APIs you wanted to use. Yeah, but it's important to check that Google Play Services is available. Next thing you need to do is to configure the Google API client. This is usually done in the onCreate method of your activity. So you can add any number of APIs that you want. So in this example, we've got the Google Drive API, and we've got the Google Plus API. Also, you need to choose the appropriate scopes that you want to use. So, for example, for Google Drive, this means if you want to access the user's drive, you need to choose if you want to access the whole drive or just the folders and files that the user created with your application. This is what scopes are for. So when configuring the Google API client, you add APIs and you add the scopes. Next thing you need to do is add connection callbacks and failure callbacks. So you want to be notified if the connection actually was successful or if there was a problem. Then in onStart in your activity, you connect the Google API client, and in onStop, you disconnect it. So to make sure that when your activity gets put into the background or your application will be terminated, that you actually disconnect from Google Play Services. Let's have a look at the callbacks. So these are the good callbacks, the ones that you're interested in. They actually tell you, OK, everything is going fine, like we are being connected, or the connection needs to be suspended because the application is going into the background. So in the unconnected callback, you can start working with the Google API client. And in connection suspended, you want to disconnect, and you want to disconnect your UI from anything that's being connected to Google Play Services. But life is not always great. Bad things may happen. So you might run into problems. You can't connect. The connection has failed. Or, and this is a much more common thing, you are trying to connect, but the user has not yet granted consent to use the APIs you want to use. So in this case, you need to have a look if there is a resolution for the connection failure, and then start a resolution intent. So this is what's happening in this line here, and start resolution for result. So we're having a look at the connection result. And if there is a resolution, we're starting an activity which will then display a consent dialog for the user to accept that your application wants to connect to Google Play services. And if this doesn't work, then you need to display an error dialog. Let's have a look at some of the services that we offer. So we offer a whole range of services, and today we're trying to have a look at a few of them. So we've got Google Drive, we've got Google Drive, we've got Google Maps, we've got Street View, we've got Google+, we've got activity detection, and we've got app indexing. Let's first have a look at Google Drive. So Google Drive is a cloud storage provider running on Google's infrastructure. Every user who is on Google gets 15 gigabytes for free. And we've got automatic synchronization between the various clients. So no matter on which device you create a file and store it on Drive, it will be synchronized to all of your other connected devices. We've got clients for a range of operating systems, such as Mac OS, Windows, obviously the web, and iOS and Android. And we've got a few UI-related controls for enabling you to pick and create files. So how to connect to Google Drive? We need to set up our Google API client, and we need to add the Drive API, and we need to choose the appropriate scope. So when you're using the Android SDK for connecting to Google Drive, you've basically got two scopes that you can use to connect. One is the file scope, and the other one is the app folder scope. The file scope enables you to, as an app, to create and read files with the user's permission, but you can't have a look at the whole drive. So if you're connecting using the file scope, you can only see the files and folders that the user created using your application. You cannot see everything else that's in the drive of the user. And this is for a good reason, because we want to avoid that an application asks the user for permission to access a file and then reads the whole drive and does something malicious with the contents of the drive. The second scope is the app folder scope. And the app folder is a very interesting thing because it's a special folder in the user's drive. The user can't see the app folder. It's invisible. Your application can see the app folder when it's asking for permission to access it. And it can use this folder to store configuration files that need to be synced between the various incarnations of your application. So that's very useful for storing configuration data that you want to transport from one device to another device. We've got a number of other scopes, and there actually are scopes that allow an application to access the whole drive. However, they are not surfaced in the Android SDK. So if you want to access the whole drive, you need to use the Java SDK for accessing Google Drive. So let's have a look at how to list files. In this code snippet, we've got an activity which uses a result callback, which will be called whenever we get a callback from Google Drive, basically. And in the onCreate method, we basically connect the UI, which is a list view. We use a results adapter to mediate between the model and the UI. And when the user scrolls, we ask Google Drive to provide us more data in the retrieve next page method. When we stop the activity, we disconnect, and we disconnect the results adapter. And as soon as we connect, we ask Google Drive to provide us one page full of data. And here is the method retrieve next page, which basically uses the query builder to access the Google Drive API to fetch one page full of data. And you can use the query builder to build queries like list me all files that are of a certain MIME type, or that have a certain file extension, or have a specific name, and stuff like that. But for this example, we're basically listing all the files that the user has created before. So you can see down there, the access to the Drive API works a little bit like that. You use the Drive API query method, and then you hand in the Google API client that you created before. Also, you hand in the query that you created just the 2 lines above, and then you set the result callback. And as soon as Drive gets back to you, your activity will be called with the next method, with the onResult method. So in the onResult method, you get a result. You need to cast this over to a Drive API metadata buffer. And then you can have a look into this metadata buffer and fetch the result. So what we do is we basically get the buffer, and we get the next page token so that we know how to get to the next page full of data. And then we have a look if we actually have a next page token, so we know if there is a next page or not. But why create a file picker on our own when there is something built into the system? So we've got a nice file picker, which looks like this. You can use it to pick files and folders. And here is how you use it. You basically create an intent. And in the configuration for the intent, you can choose if you just want to fetch regular files, in this example, plain text files or HTML files, or if you want to fetch folders. So there's the constant for fetching folders. And then you start an intent sender for result using this intent, and ask the system to display the dialog for you. When the user has picked a file and has confirmed the dialog, you will be called back in on activity result, and you can have a look at the request code, if it's actually a request code that is being sent because you asked the system to do something, and then you have a look at the result code, and if it's OK, then the user has chosen a file or a folder. Then you get the parsable extra from the data field, and you can display, you can get access to the ID of the file that the user actually chose. So it's in the Drive ID field that you read from get parsable data. All right, so this was Google Drive. Another API that I'd like to talk to you about is activity recognition. For this, I need a volunteer. OK, so can you please all stand up? All right. So everyone who has an A in their name, please keep standing. Everyone else sit down. Wow, amazing. Everyone whose first name is shorter than 6 characters, keep standing. Everyone else sit down. OK. All right. So everyone who is an Android developer, keep standing. Everyone else sit down. Awesome. OK. So I'm going to randomly pick you. Give a round of applause for our volunteer. What's your name?
Mark.
Mark. Great, Mark. So what we're going to do, can you do planks?
No.
No? You can't?
I don't know what that is.
OK, I'll show you.
Text-to-speech initialized.
OK. So I'll show you what a plank is. So you basically get down like this. Can you do this for us? Yep, try it. OK. But wait. So you need to take the, can you stand up again? So we're putting this into your back pocket.
Wow, those are some killer planks, dude. Oh no, don't just sit still.
OK, do some planks. All right. A few more.
Wow, those are some killer planks, dude. Wow,
awesome.
Those are some killer planks, dude. Wow, those are some killer planks, dude. Wow, those are some killer planks, dude. Keep going, keep going, keep going, keep going.
Round
wow,
of applause
those
for
are some
Mark.
killer planks.
Thank you. You can sit down. So what's happening is the device uses a low-power background process to detect the user's activity. So actually, it's not the best use case to use it for fitness applications because it's honestly made for things like detecting if you are walking to the bus, if you are on a bike, if you are in a train, on a car, if you're running or walking around. Unfortunately, our lead is not long enough to demonstrate driving or walking around. But it does recognize tilting. So when I tilt the device like this, it will take a few seconds.
Wow, those are some killer planks, dude. Wow, those are some killer planks, dude.
Until it recognizes that the user is tilting. And so because I thought it was a nice gimmick to have someone come up and do some planks, I translated tilting to planks. But basically, it detects you're picking up the device and putting it down again. So how do we use this API? So we've got the activity recognition API. And you probably recognize this pattern by now. You configure your GoogleApiClient, add the activity recognition API, and add a callback. Then you need to adjust the permissions. So you need to ask for a permission to use activity recognition in your manifest file down here. And then we start the activity recognition by getting a pending intent, and then requesting activity updates. And the parameters we're sending in are our GoogleApiClient, then the detection interval. So for this demonstration, I use 100 seconds, which is very, very short, and you probably should have a much longer interval for using it for low-power background activity detection. And then you need to send in your activity recognition pending intent, which we just configured up here, because this will be called back as soon as you get some updates. And then you need to have another activity which will be called back as soon as you get the updates. And this is how you configure it for, so we set it up using an intent filter, and it's a service. And then in onHandleIntent, we have a look at the intent and have a look if we actually get an activity recognition result. And the result has a number of fields that are interesting. So first of all, we can see what's the most probable activity that it has detected. It delivers a confidence level from 0 to 100. So if it's very low, you can choose to not act on this activity result, but just wait. And then we get the activity type by having a look at most probable activity.type, which is just an integer, basically. And then we can translate this type into a string for displaying it in the UI, or in our case, for sending it to the text-to-speech system. And that is activity updates. Next up, Google Maps. So you've probably seen the Google Maps talk earlier today, but I'm going to focus on a few other aspects of Google Maps. First of all, in order to set up Google Maps, you need to obtain a Maps key, and this is a little bit complicated. So here is how you do it. So you go into the developer console. You go down to create a public API access key. You choose to create an Android key. And then you need to insert your SHA-1, which we used earlier, a semicolon, and then the package name of your application. And when you've done this, you will end up with a new API key, and this, which is scrapped out here, will be the API key you'll use in your manifest, actually. So in your manifest, you need to insert the Maps key, which we just created. Then another good thing you need to do is to specify the Google Play Services version. So this is basically something which you need to do in all of the applications that I showed you. You need to specify the version of Google Play Services that you want to use. And it's a good way to use this constant. And then we need to set up the permissions. So because Maps accesses the internet, we need to require access to the internet. We want to have access to the G-services provider. We need access to the external storage because all the Maps tiles that will be downloaded need to be stored somewhere, so they are cached and you don't blow up your data rate. Maps also has a look at the network state to figure out if it actually can download new tiles. And then the final two permissions down here basically are in place so that the user can tap on the pin to let Maps detect where he currently is. So it's a good idea to have those two permissions as well. So I want to show you how Street View works, and the picture here actually is the Google office in London. And if you go there, you might actually see one version of Street View where all of the Google employees in London are standing outside and waving. So in order to use Street View in your application, you have to set up a layout like this. So we've got a Street View panorama fragment that you just can reuse like this. And then in your onCreate method, you basically connect the view, and then you find the fragment, and then you can just set the position. So in order to set the position, you send in just latitude and longitude, and you can use Google Maps for finding out the latitude and longitude of interesting places if you just go into your browser. many applications that use Street View let the user move around to simulate driving or walking. And this is how you can do that. So we've got a camera. And you can update the position, the zoom factor, the bearing, the tilting, and other factors of the camera like this. So you create a new camera with the panorama camera builder. You set the zoom factor, you set the bearing, you set the tilt factor, and then you build it. And then on the Street View panorama view, you basically ask it to animate from the current position to the next position of the camera that you are setting in this last line. So that's the camera. And then you ask it to animate to the new position of the camera. There are a couple of other things that you can configure. So you can configure whether the user can move around in the Street View panorama, if they can navigate, if they can zoom, and also you can configure whether the street names are being displayed or not. Another thing that you can use with Google Maps are indoor maps. And what you see on this map is the indoor view of the Google office that I just showed you from outside. And my personal desk is up here. So this also is very easy, actually, to set up. So what you need to do is you provide the map fragment in your layout file. Then in your onCreate method, you are connected to your UI. And then you set up a new camera. You position the camera to a latitude and longitude. And then the 18 is an important number because this basically is the zoom factor. And you have to play around with this a little bit in order to find out where exactly you need to position the camera in order for it to show you the indoor map. And then finally, you ask the map to move to the camera. And that was Google Maps. On to Google+. So I don't know about you, but a lot of people think Google+, wow, why? But bear with me. Google+ is an interesting API that we provide. It has got a number of interesting properties. Probably the most important one being that it's a powerful identity provider. So I don't know about you, but I'm so annoyed when I go onto a website and I have to come up with a new username and password. And if you use Google+ as an identity provider on your website, basically users can sign into your website without ever having to come up with a new username and password combination. They just sign in once, and then they can sign in to your website without having to enter a new password. Another thing why you might want to use Google+ is by using Google+ on your website and in your application, you can actually drive installations of your Android application. And I will show you how this works in a minute. Another thing that's pretty interesting about Google+ is that you can drive user engagement by interactive posts. So interactive posts are like regular posts, but they have a call to action button. And if another user presses the call to action button on the mobile device, it will actually jump back into your application. And I'm going to show you how this works now. So over-the-air installs. One of our partners, Fancy, uses Google+ sign-in on their website and also in their Android application. So if you go to their website, which looks similar to this one, and you click on sign in, you've got a number of sign-in options, Google Plus being one of them. If you click on sign in with Google Plus, you will see this constant dialog, which basically tells you Fancy would like to see your username and your profile information and a couple of other scopes they are asking for. Then in the next step, the constant dialog will basically show you the question, would you like to install the companion application on your Android device? And if you accept, the application will automatically be installed onto your Android device, and you will be signed in without having to click on the sign-in button on your Android device with your Google account that you use to sign into the website. That is over-the-air install. In order to use over-the-air install, what you need to do is you need to use the Google Plus sign-in button on your website. You need to set the Android app package name into the Google Plus button on your website. You need to ensure that you're using the same scopes in your application on the website and in your Android application. And then finally, configure the content screen with a name for the application and a logo. And you need to meet certain quality thresholds. So your application needs to be free. It needs to have a certain number of stars. It needs to have a certain number of users already. And meeting all those requirements, over-the-air install will actually work like this. Interactive posts is another thing that Google Plus brings to you. So an interactive post looks like this. If you send a post in your application, the user can actually enter text in here. And then in the Google Plus application on the mobile device, you will have this additional button down here. And if anyone who clicks on this button has your app installed, they will be taken straight into your app, into the place that you specified. So you can send a URL which points to a screen in your application. Of course, you need to parse the URL and decide which screen that will be. So to do this, you need to set up a few permissions down here. So access to the internet, access to the accounts, and to the credentials. And then you need to set up the call to action URL and the call to action deep link ID, which will be used to jump into your application at a later point of time. Then you set up an intent using the Plus Share Builder and start an activity with this intent. And this will basically start the screen where the user can edit the post and then send the post. Finally, in order to jump back into your application, you need to parse the deep link. So first of all, you need to configure an intent filter that will be called when a user clicks on a deep link. Then you need to process the deep link ID down here and on start. And this is how it looks like. So you basically take the deep link, you check if it's starting with the deep links that you care about, and then you do something with it. In this example, we're basically showing just a toast. OK, to quickly recap, what we're seeing today is a couple of APIs that you can use in Google Play services, but there are many, many, many more. And it's impossible to talk about all of them in just an hour. So I encourage you to go to developers.android.com/google/play-services and have a look at all of them. And with that, if you've got any questions, feel free to ask now, or I'll be around for the rest of the conference so you can ask then.
Hi, my name is Rahul. I'm from Turner Broadcasting. So does these Google Play services also help the notification services, like the push notifications coming in from?
Yeah, so that's basically cloud messaging.
Right.
And you can use Google Cloud Messaging to send push notifications to Android devices and also to iOS devices.
So let's say I kill the app. Are they still running in the background, still listening to the coming in messages, or does the app has to be up and running in the background?
Yeah, so basically you set up a service which will listen to incoming remote intents. And then as push notifications come in, your application will be started up, or the service, actually.
So there's going to be special configuration for that, or?
Well, it's basically you need to set it up in the developer console for one, and then also in the Android manifest, so that you that your application knows which part of the application to start when a remote intent comes in.
Okay, thanks.
You're welcome.
Hey, my name is Senthil. So one of the primary problems that we face with Android development is the DEX limitation, especially with Google Play Services 5. I think like we have some 30,000 methods in Google Play Services, and we end up exhausting the method limits. So have you guys have any solution for it yet?
Can you repeat?
I'm talking about the DEX limitation. Like you can have only 65,000 methods in your whole application, right?
Oh, the DEX limit.
Yeah.
Yeah. Yeah. So the best solution probably right now is to use ProGuard to limit the number of methods that you got and strip out anything that you don't need. And other than that, well, actually, we are aware of this problem, and you will probably see a solution for that pretty soon, but there's not much more I can tell you right now.
Okay, thank you.
All right, so in case you've got any other questions, feel free to track me down afterwards. I just wanted to call out 2 other sessions that you probably find pretty interesting. One of them being the Material Android Design from Concept to Implementation session, which is on Thursday at 1 o'clock in Franklin. And then the other one is C# in my eyes and in my ears about wearable technology on Thursday at 4:15. And we've got some Android Wear devices in the Darwin Lounge. So if you want to get your hands on Android Wear watches like this one, head down to the Darwin Lounge and play around with it. And we actually have got a number of Moto 360 devices over there. So go ahead and hack around with them. And if you come up with something interesting, just let me know. Thanks.